Bit of history. Kerberos is a network authentication protocol of the sense that we've been talking about. So you have a network where you have a centralized server that manages keys that it shares with the clients on the network, and they can authenticate each other by making use of this central KDC. Kerberos is named after the three-headed dog that guards the gate to Hades. I think in Europe we call him Cerberus, but this was from America, they called him Kerberos. So that's this where the name comes from. So the idea is it's providing some kind of security, and the three heads are for the three different participants, if you like, or three different aspects of the protocol. It was invented at MIT in the late 1980s and just used locally from their point of view initially. It's based on a key distribution system with, so where there is a trusted third party, that's a server. And this is a kind of strapline, provides centralized third-party authentication in a distributed network. So you have a distributed network, you have people that haven't necessarily spoken to each other before, but they're all part of the network, and they all have some key that they share with the center. And the idea is that it also allows users access to services distributed throughout the network. So if I log on to the network in the department, and I then want to access a printer and send a job to the printer will only accept the job if it can authenticate me, if it knows where the job has come from. So it would be using Kerberos, or it would be using the Windows version of Kerberos, or something like that, in order to provide that authentication. So when I want to access something in the network, then there's something like this going on underneath. And it can you can trace the ideas back to the Needham-Schroeder symmetric key protocol that I just showed you, and the Denning-Sacco development of that, which introduced timestamps. So that's where it comes from. Those are the kind of design ideas that it's based on. So it has at its heart a key distribution center. So the key distribution center is what manages the keys that are shared with the various participants on the network. So that has to run somewhere that is physically secure, that nobody can get to, because it suffers from the same kind of concerns as any key distribution center. It's a single point of failure. So if somebody is able to attack that to get hold of the keys, then the whole network security is undermined. Okay, so that needs to be somewhere that's physically secure and somewhere on the network that is accessible on the network. So the idea is that a user will log into a workstation, a local terminal, with their username and password. That's how they get into the network. The username and the password are going to be used by the workstation locally to obtain information from the KDC that will then be used to access remote resources on behalf of the user. Okay, so I'm the user, my terminal is doing all of the work, and I want to do various things, so my terminal will get hold of tickets that it can use to access resources on my behalf. When I want to print something, when I want to access some remote file store, then the workstation will have things locally that will allow it to do that. So the KDC shares a secret key, which in Kerberos is called a master key, with each principal. Okay, so I'm a principal. I will share a secret key with the key distribution center. Okay, so with the network. So here's the kind of structure. This is the KDC. This is Alice, who wants to access various resources on the network. Alice is interacting by means of a client, so this is a computer. It's a workstation that Alice is making use of in order to work. And then there are various services or other participants on the network that Alice wants to access. Okay, so Bob, in this case, is a service that Alice will want to access. So Bob will want some kind of authentication that the requests that are coming along are genuine and are allowed by people that are, that have a right to be on the network and should have access to those services. So Alice will request, let's say, that she wants to talk to Bob. Okay, she wants the service that Bob offers. The KDC will invent a session key. So this is issuing a particular ticket. Will it invent a session key for Alice and Bob to use for that session? Okay, so this is the part down the bottom. That will be encrypted with Alice's master key for Alice to use. So that's the master key is the key that Alice shares with the server, with the KDC. So this whole thing will be encrypted with Alice's master key. And that same session key will be also encrypted with Bob's master key, or the key that Bob has with the server. And that's going to be a ticket. So that's very much like what happens in the Denning-Sacco development of Needham-Schroeder. Okay, so there will be a ticket. So there's identifying information regarding Alice that's included with Bob's master key. So that's what a ticket will look like. Only Alice and Bob can know this. That key and the ticket together are known as Alice's credentials. In other words, they are what Alice uses to authenticate herself to Bob. To say, this is, I really am Alice. I've been checked out, and this ticket has been issued by someone that is able to check me out, that you trust. The tickets include timestamps, and they're only therefore valid for a certain length of time. Okay, so after a while, they will time out. Okay, they will no longer be valid. So that's what prevents replay attacks. A ticket that's issued will have a timestamp in it. So the way it's configured, the KDC maintains a database of the principals and their master keys. So each one has a master key KAS for principal A, and the KDC maintains all of that. Okay, now the KDC itself has a master key. Okay, so this is the master key for the KDC. And that's a personal secret of the KDC, so nothing else knows that. It doesn't share that with anyone. All of these other keys are shared between the master key and the KDC itself. So the way they're stored is encrypted with the KDC master key. So if anyone is able to get hold of these that are being stored, they are still encrypted, at least, so the keys are not all immediately blown away. Okay, now what happens in practice is humans are not very good at remembering 128-bit sequences. So typically the master key for human users is derived from their password. Okay, because humans are able to remember passwords but not secret keys. So you won't know what your secret key is, but actually the system will have generated it in some way from your password. For example, as a hash of your password. And in practice, the cryptography that's used within Kerberos is DES. Okay? So these keys, these master keys, are going to be DES keys. That's what happens in practice. So what will happen is your particular password will be transformed in some way that where it can't be reversed to generate a master key. So your password is able to is used to generate your master key. It's that master key that is stored there. So let's look at step one. So here's the authenticating service initiating the session. So Alice sends her username and password just locally to the local workstation. So she types that in. So that doesn't go over the network, that's just local. And what the workstation sends here is to the KDC is a request. Alice needs a ticket granting ticket. So Alice has now logged in for a session and she's going to want to access various services. So please, can you set that up? And what the KDC does is invent a session key for Alice. So, and that session key will be SA. So that's just for this session. So this is set up for Alice to use when she's asking for individual tickets. Okay. That is then sent back to the workstation, encrypted with Alice's key. Okay, Alice's master key here. So this session key is encrypted, and then here is the ticket granting ticket. So what does that mean? Well, that's going to be something which Alice can use to send to say, I'd like a ticket for this particular service, please. So this here is encrypted with the KDC's master key that nobody knows apart from the KDC. So when this is received by the KDC, it knows that it must have encrypted that. And what it says inside is, this is a ticket granting ticket for Alice. This is the session key that I've just sent to Alice. So that's what I'm expecting Alice to be using, is this session key. And here's a timestamp. So don't accept this ticket after this timestamp has expired. Okay, so that's what's sent back to the workstation. So I think, again, that's what I've said here. What's going on? The reason this session key is used, so when Alice types in the username and password, because there is a way of generating her master key from the password, this workstation is able to generate the master key from that, and therefore can use the master key to decrypt this. Okay, so this username and password gives the workstation this key. So it's like Alice, essentially you could think of it as Alice using her key to decrypt this. So the password is never sent over the network. Okay, that would be a bad idea. This here is just local. This isn't a network interaction. There's nothing going over the network. That's just Alice typing into the workstation. Okay, so the password is not sent anywhere. What comes back is something which the workstation can decrypt. The idea of using a session key, the session key is going to be what's used, is that you want the workstation to forget this master key as soon as it can. So that's a design element of this protocol. Because workstations are not necessarily as secure as the KDC, what you'd like is that as soon as Alice has been through this step and received this back, that the workstation can say, right, I don't need the master key anymore, I'll dump it. So it's going to be in memory for as little time as possible. Okay, so there's not really a window to attack that. It's not going to be hanging around for the entire session. So this session key is going to be hanging around for the entire session. Okay, but that's going to expire. So if that's compromised, all that's lost is the individual session. So that's what this is saying. Use of that session key means the workstation can forget Alice's password, in other words, the master key, after decrypting this initial message that comes back. And what this ticket is going to do, so what we've done here is create a session key that Alice is going to use when she wants an individual ticket. Okay, so that's creating a session key for Alice to use with the KDC. So here's step 2. Here's how Alice gets individual tickets for sessions with a particular server. So now we'll say Alice wants to access Bob. So Alice tells the workstation, I want to log into this particular server. So I'm going to do rlogin to Bob. What the workstation does is tell the KDC, now in its second role as a ticket granting service, so this is now going to issue individual tickets, Alice wants to talk to Bob. And here is my ticket granting ticket. Okay? So my ticket granting ticket is to remind the KDC of what this session key is. So, and to remind the KDC that I was authenticated earlier on. So, and then Alice also sends an authenticator, which is a timestamp encrypted with this session key. So that says this was fairly recent, and I do know this session key, which no one else knows. So getting all of this together tells the KDC that this is a request from Alice. And this is the ticket that is sent back for use with Bob. So what goes on there is it's encrypted with Alice's session key, which no one is going to be able to decrypt apart from Alice. And Bob, what it contains in it is the session key for Alice to use with Bob. So again, this is just like Denning-Sacco, together with the name that says this is for Bob, just in case anyone's spoofing, this bit here. And this is the ticket that you then need to pass on to Bob. It's encrypted with Bob's master key. Okay? And it's saying, here's a timestamp that's fairly recent. Here's the session key that Alice wants to use with you. And I've authenticated all this and it's all been checked out. Alice has the right to communicate with you and so on. So this is the ticket for Alice to use with Bob. Now the point of giving Alice this ticket granting ticket, let me go back, the ticket granting ticket looks like this, is it has the session key included in it. So what that means is the KDC does not need to remember the session key. Because what will happen is every time this arrives, the KDC knows that it encrypted that, so it's reminded that this is the session key for Alice. So again, you don't have the overhead of the KDC having to remember all these session keys that it's given out. What it's done is encrypt it in a way that Alice can say, look, this is the session key you gave me, you remember? And it says, oh yes, I remember, that's what I'll use. So it can do that every time. It doesn't have the overhead of having to store anything. It's all in here and it can do it during the protocol whenever it gets a request. So that's the point of this ticket granting ticket coming back in. It reminds the KDC of this session key that is used. So what's happened by the end, it's authenticated for Bob. This ticket is authenticated for Bob by the fact that it's encrypted with Bob's master key. So then Bob says, well, this must have come from the KDC because that's the only thing that's got my master key. So therefore, the earlier steps have all checked out. So that's step 2. So then step 3, the workstation sends this message to Bob saying, I'm Alice, or Alice would like to talk to Bob. Here is the ticket for Alice to talk to Bob, and here is the current time encrypted with that key. So the person sending this really does know the key that's inside there. So again, that stops anyone else spoofing anything, because no one else can create this because they don't have that key. So that provides evidence that that was sent by the person who possesses that key. And then to give the workstation confirmation that it received Bob, we look at the timestamp +1. So this here that came through, we add 1 to it, send it back, and again that shows the workstation that it really did reach Bob. So Bob guards against replay attacks by checking the timestamp is sufficiently recent, so this can't be coming from anyone else. In practice, that's typically about 5 minutes. So you have a 5-minute window from getting your ticket to actually cashing it in with Bob. And then it can even guard against replay attacks in those 5 minutes by storing all the requests during that time and then checking for any repeats. So if there is a replay attack, in other words, Eve remembers this and then sends it within the 5 minutes, it's certainly straightforward for Bob to remember just the last 5 minutes worth of requests and to check that anything coming in is recent, is not replayed. Anything outside that 5 minutes will be rejected just because it's not recent enough. So that, again, that's what happens in practice to prevent any kind of replays at all, even within the recentness window. So after that has happened, both Alice and Bob know that the other one has this shared session key and they can interact. And they can use that shared session key, or actually if they're not worried about confidentiality and they just wanted authentication, then they know they're talking to each other and they can communicate. But they can use that shared session key if they want to. So that's Kerberos in a nutshell. There are various versions of Kerberos actually. It has been developed. The two that are mainly in use are Kerberos 4 and Kerberos 5. and there are differences between them, mainly to do with where information is stored and how long it's stored for, and so on. But there are certainly a number of developments of Kerberos. So in summary, there are authentication protocols and key distribution protocols with symmetric key cryptography that make use of key distribution centers, which look after the master keys, and then they share out, and then they're used as a kind of platform to set up individual sessions between different participants on the network. And protocols are just ways of exchanging these messages in a way that's secured by the cryptography. You can include key generation and distribution within this. And typically nonces or timestamps are used to establish recentness or some kind of combination of the two. And in practice, tickets are used to be efficient. So rather than having the key distribution center or the server as some kind of matchmaker that's setting up Alice and Bob to talk to each other, the server will only talk to one of them and say, here's your ticket, to talk to the other two and show that you've spoken to me, and I'm happy with that, and they have the guarantees. So tickets are typically used in practice. Protocols are difficult to get right. I hope I've got that across as well. There are published protocols that have flaws. If you make a small change to a protocol, it can affect the security quite dramatically. What may happen in practice, you may have read about a protocol, you may know about Kerberos, and in your system you need to do something which is slightly different to what Kerberos does. So you go in and you make a change, and you change some of the messages that are in there, or one of the messages, that might introduce a flaw that wasn't there before. Because that message was made sure that a certain attack didn't happen. So it's very difficult to get these things right, and therefore you need to do some kind of analysis on these protocols to be confident that actually you haven't introduced those kind of flaws.